Hello everyone, and welcome back to our lecture series. Today we're going to be looking at acceleration formulas. When an object accelerates, there are only two formulas that will basically apply to it, with the exception, of course, of the formula for acceleration itself. So what are these two formulas? The first one, it is called distance time formula, and it is characterized with d equals vi, which is velocity initial, times t, which is time, plus 1/2 a, which is acceleration, times time squared. Remember, when you're using this formula, do not forget to square this time. And the second formula is going to be timeless. Vf squared, velocity final squared, equals velocity initial squared plus 2 times acceleration times distance. So here's the biggest trick of when to know to apply which formula. If time is given, you will clearly use the distance time formula, whereas if time is not given, you're going to use the timeless formula. It's pretty much as simple as that. Let's solve right away our first problem. It says, a car accelerates uniformly from rest at 3.2 meters per second squared. Calculate the speed when it's traveled a distance of 40 meters. The best way, most effective way to do this is to actually do a t-chart. And we do a known versus unknown, meaning what they're asking us for chart. Okay, so a car accelerates uniformly from rest. So what does that mean, from rest? It means that velocity initial is 0 meters per second, of course, at a rate of 3.2 meters per second squared. That, of course, is the acceleration. So 3.2 meters per second squared. It says to calculate the speed, if we're given final initial velocity, we're being asked to find the final velocity when it has traveled a distance of 40 meters. Okay, so let's see which formula we should use for this one. As you can see over here, no time is given and no time is asked for. Therefore, we are going to use timeless. That is velocity final squared equals velocity initial squared plus 2 times acceleration times distance. So, we're trying to find velocity final. That's what they're asking us for. So now we're going to take velocity initial, which in this case is going to be 0. I'm going to square it, plus 2 times the acceleration. As you can see over here is 3.2 meters per second squared, times the distance traveled, which of course is 40 meters. So, we're going to ignore this because that 0 squared is of course going to be 0. And we do 2 times 3.2 times 40. And if you put this in your calculator, you're going to see that it's going to be 256. But that's the velocity final squared, which is 256. To find the actual velocity final, we got to take the square root of both sides. And we see that velocity final, the square root of 256, of course, is going to be 16 meters per second. Pretty simple. Once again, if time is not given, if time is not asked for, you're going to use this formula over here that is called timeless, and no time is in its variables. Let's solve another problem. An object traveling at 20 meters per second accelerates uniformly at 6 meters per second squared for 2 seconds. What is the displacement of the object? Again, we do a known versus unknown chart. So, as you can see over here, an object traveling at 20 meters per second, that's of course our velocity initial. So 20 meters per second, that's our velocity initial. It accelerates uniformly at 6 meters per second squared. Notice the units for acceleration, of course, are going to be meters per second squared. So 6 meters per second squared. And notice the difference. This is simply meters per second. This is meters per second squared. And the time now is 2 seconds. And you're being asked for the displacement or the distance traveled by the object. Look at your variables very carefully. Do they give you time? The answer, of course, is yes. The time is 2 seconds. Therefore, you have to use the distance time formula. That is, distance equals velocity initial times time plus 1/2 acceleration times time squared. So, we're trying to find the distance. velocity initial is going to be 20 meters per second times the time, in this case is going to be 2 seconds, plus 1/2 the acceleration, which is 6 meters per second squared, times, of course, time squared. And please do not forget to square the time. Okay, let's solve this. 2 times 20, of course, is going to be 40. We put this right here. Plus, so we do first the products. And we go on this side now, because it's united by positive. 2 squared is 4. 4 divided by 2 is going to be 2. So 2 times 6 is going to be 12. So 40 plus 12 is going to be 52. And the answer, of course, is going to be 52 meters, as you can see over here. Well, let's do another one. An object at rest accelerates at 5 meters per second squared until it attains a speed of 30 meters per second. What is the total distance traveled? So let's do again our T-chart of known versus unknown. So what do we have here? It says the object accelerates at 5 meters per second squared. So the acceleration, of course, is going to be 5 meters per second squared until it attains a speed of 30 meters per second. And it says that the object starts at rest. So velocity initial is 0 meters per second. Velocity final now is going to be 30 meters per second. And we're being asked for the total distance traveled. Let's look at all of our variables. We have distance, acceleration, velocity initial, and velocity final. No time is given. Therefore, it's a no-brainer. This is going to be the timeless equation. So velocity final squared equals velocity initial squared plus 2 times a times d. So velocity final, of course, it's going to be 30 meters per second, and we're going to square that, equals velocity initial. Now it's going to be 0 squared, so I can just simply go right ahead and omit this, so I can also save some space. 2 times the acceleration now, which is 5 meters per second squared, times the distance, and that's what we're trying to find. So 30 squared, everybody would agree, is 900, and 2 times 5 is going to be 10 times distance. We divide both sides by 10. This cancels out. So we see that the distance is going to be 90 meters. And that's our answer, 90 meters. Now for the last problem, we're going to now utilize our knowledge of vectors. So it says, an object traveling north with an initial velocity of 19 meters per second accelerates south at a rate of 4.5 meters per second squared for 3 seconds. Find the displacement. So, this case, we have to now define what's positive and what's negative, because we have two things that point in opposite directions. So we're going to use the same exact thing as the XY axis system, and we're going to say that north is positive and of course south is going to be negative. So let's do our T-chart. Here it is, known versus unknown. So an object traveling north with an initial velocity of that. Because it travels north, we see that as positive. So it's going to be, so our velocity initial is going to be positive 19 meters per second. It says accelerates south at a rate of 4.5 meters per second squared. So south, we see right here, is going to be negative because they're pointing in opposite directions, and these are vector quantities. So the acceleration now is going to be negative 4.5 meters per second squared. For 3 seconds, and time, of course, is going to be 3 seconds, and they're asking us to find the displacement, or the distance. Let's look at all of our variables. We see clearly over here we have time, so therefore we're going to use the distance time formula in order to find this. And what is it? Distance equals velocity initial times time plus 1/2 at squared. Let's plug everything in. Distance equals velocity initial is going to be now positive 19 meters per second times the time, which is 3 seconds plus 1/2 acceleration. And please be careful, acceleration we said points south, so it's going to be negative. So the acceleration now is going to be negative 4.5 meters per second squared. And the time, of course, is going to be 3 seconds, and the whole thing is going to be squared. Now, because they're unified by positive, let's first do the calculation on this side, and then let's do the calculation on this side, and algebraically add them or subtract them. 19 times 3, I believe everybody would agree it is 57, okay? And of course, these seconds cancel, and then it's meters. And now, we quickly see here that we have positive times negative times positive. So that's going to make it, instead of positive now, the sign is going to flip, and it's going to be now negative. So 3 squared, that's going to be 9, okay? Divided by 2 is 4.5. 4.5 times 4.5, it is going to be 20.25, and second squared cancel out, so we're left with the meters. So now we subtract these two in order to find the distance. 57 minus 20.25, everybody would agree it is positive 36.75 meters. In other words, it decelerates as it's moving up north, it decelerates by 4.5 meters per second squared, and because it's pointing in the opposite direction, it's going to slow down, and it is going to travel a distance of 36.75 in the positive direction, which in this case it is north. Thank you very much. See you in class.